Have you ever wondered why you can't catch up with light, no matter how fast you run? It's a fascinating conundrum, isn't it? This is because light, like a relentless runner on an endless treadmill, always stays ahead. No matter how swiftly you sprint, the speed of light remains constant and unattainable. It's a race you simply can't win. So, while you may be fleet of foot, light is eternally elusive. In essence, light is always one step ahead, forever out of reach. But light is more than just a fast runner. In fact, it leads a double life. Picture this. Light is a master of disguise, sometimes appearing as a wave and at other times masquerading as a particle. This is what scientists call the wave-particle duality of light. How does this work, you may wonder? Let's imagine the particle side of light first. Think of it like a game of paintball. The paintballs are like packets of light known as photons. These photons are tiny, fast-moving entities that can hit and interact with things. They're the reason we can see objects. When a photon hits an object, it might bounce back to our eyes, allowing us to perceive that object. Now let's switch gears and imagine light as a wave. Think about throwing a pebble into a calm pond. The pebble disrupts the water, creating ripples that spread out from the point of impact. This is a lot like how light waves behave. They spread out and can even bend around obstacles, a phenomenon known as diffraction. This wave nature of light is why we can see light spread out from a lamp and fill a room, or why we can still hear someone's voice even if we're not directly in front of them. Sound also travels in waves, much like light. The intriguing thing is that light doesn't choose to be a particle or a wave. It's both all the time. Depending on the circumstance, one aspect might be more apparent than the other. For instance, when light interacts with matter, its particle nature becomes evident. And when it travels and spreads out, its wave nature takes center stage. This dual nature of light is a fundamental concept in quantum physics, and it's another testament to the fascinating complexity of our universe. Light, in its duality, challenges our understanding and forces us to think outside the box. It's a beautiful enigma, being both a particle and a wave at the same time. So, light is both a sprinter and a swimmer, darting around as particles and flowing as waves. Now imagine a world without colors. Pretty dull, right? Well, thank light for the colors you see. It's an absolute marvel how light brings the world to life with its vibrant spectrum. You see, light is the very reason we perceive color. But how does this happen? Let's break it down. When light, a form of energy, falls on an object, it's either absorbed, reflected, or transmitted. The colors we see are actually the light wavelengths that are reflected and not absorbed. For instance, consider a ripe, juicy red apple. It appears red because it absorbs all colors of the light spectrum except red, which it reflects back to our eyes. And speaking of eyes, our peepers play a critical role in color perception. Inside our eyes are the light-sensitive cells called cones, which respond differently to light of different wavelengths. There are 3 types of cones, each sensitive to a different part of the spectrum. When light enters our eyes, it triggers these cones, which send signals to our brains. Our brains then interpret these signals as color. So next time you find yourself marveling at a rainbow or the beautiful hues of a sunset, remember it's all thanks to the intricate dance between light objects and our eyes. It's a fascinating process that paints our world in a myriad of shades and tones. Through light, we experience a world bursting with color. From its elusive speed to its dual nature and color-giving properties, light is indeed a fascinating phenomenon. We've journeyed through the enigma of light, unveiling its constant speed, a mind-boggling 300,000 kilometers per second that remains unchanged regardless of the observer's movement. We've delved deep into the perplexing wave-particle duality, a concept that challenges our understanding of the physical world by acknowledging that light behaves both as a particle and a wave. We've also explored how light is the very source of color in our lives, with each hue we perceive being a result of certain wavelengths of light being absorbed, reflected, or transmitted by objects around us. Each aspect of light we've discussed paints a picture of an intricate and beautiful world that's continually illuminated by this incredible phenomenon. So next time you switch on a light or look at a colorful object, remember, there's more to light than meets